NEET ꯊꯥꯒꯗꯕ ꯑꯉꯥꯡꯁꯤꯡꯒꯤ ꯐꯤꯖꯤꯛꯁꯀꯤ ꯑꯣꯏꯅ ꯁꯦꯝꯖꯕꯅꯤ ꯉꯁꯤꯒꯤ ꯚꯤꯗꯤꯑꯣ ꯑꯁꯤ ꯑꯍꯥꯟꯕ ꯂꯧꯈꯠꯆꯒꯗꯧꯔꯤꯕ ꯆꯦꯞꯇꯔ ꯑꯁꯤ ꯌꯨꯅꯤꯠ ꯑꯦꯟड ꯗꯥꯏꯃꯦꯟꯁꯟꯁ ꯑꯍꯥꯟꯕ ꯐꯤꯖꯤꯛꯁꯀꯤ 11th ꯀ꯭ꯂꯥꯁꯀꯤ ꯄꯣꯔꯁꯟꯗꯨꯅꯤ ꯁꯣ ꯁꯤꯒꯤ ꯆꯦꯞꯇꯔꯁꯤꯗ ꯑꯩꯈꯣꯏꯅ ꯊꯦꯡꯅꯔꯤꯕꯁꯤ what is scope of physics, what is physics, adagi ꯑꯇꯣꯞꯄ ꯃꯌꯥꯝ ꯌꯥꯎꯔꯤ aduna akoina khangadasi physics ase kaino what is physics Physics is branch of science which deals with nature and natural phenomena. Physics da kona nainari basi maroina kai yawi physics da yawi si ko mechanics heat and thermodynamics, oscillation and waves, properties of matter, electrostatics, current, electricity, magnetism, electromagnetic induction, alternating current, optics, atoms and nuclei, electronics. Si charakpa koina khaidokpe wani sinataba topa sub branches mayam leri aduda aina koida hainingisi medical entrance ta chumna se physics ta question 45 chemistry 45 question say biology 90 punjalaga 180 question name place sida among the hana thagraba ngang singhi ki moi khare amarabda nataba anouba thagadaba ngang singhi demak time management ji amaru hoy aduna angangsing nakona attempt to matamda kamaina pekha attempt to kata ke ai chu yam kano to maruni number 1 da say biology hana paigatani number 1 attempt to this biology question number 2 the chemistry number 3 the physics is say non-numerical na hana paini adu mathang da numerical sumain torga akona prekhaji tharagati na koida keno tawa matamji konani natragati matam piriba matamji konaba ngamoy aduna siju yam sigi awareness siju yam dakani now say uzi akoi physics si horasi say ahanba physical quantity physical quantity se akona karino haita ati so those quantities which can be measured directly or indirectly are known as physical quantity. So those quantities which can be measured directly or indirectly. Directly on bangamba or indirectly on bangamba. Aduma quantity to physical quantity. For example, we can measure the length of a room, breadth of a room, height of a room. We can measure directly. We can measure the distance between earth and sun, but not directly. We can measure the mass of the electron. We can measure the charge carried by an electron. Which can be measured directly or indirectly are known as physical quantities. Physical quantities है अगोना मखन अनि थोन खाइदोक पे है आम बता ये द based on directional property. Based on directional property, we can classify physical quantities into two. One is scalar quantity, and second one is vector quantity. So based on its directional property, we can classify physical quantity into two. One is scalar quantity and vector quantities. So scalar quantities are those quantities which have magnitude only. The example: speed, time, temperature, distance, etc. So those quantities having magnitude only are known as scalar quantities, and those quantities having both magnitude and direction, those quantities having magnitude as well as direction are known as vector quantity. The example: the displacement, velocity, acceleration, force, etc. So based on directional quantity property, we can classify physical quantities into two, that is a scalar quantity and vector quantity. And second, based on dependency. So based on dependency, we can classify physical quantity into two. Number one, fundamental, or base quantities, and second one, derived. So fundamental quantities are the length, mass, time. Length, mass, time are known as fundamental quantities. Hadi moi masa na atopa quantity anta yaudana masa mathanta na express tokjaba ngamba quantity adubu fundamental quantity ka hui, while derived quantities are those quantities which can be expressed with the help of fundamental quantities. So those quantities which can be expressed with the help of the fundamental quantities are known as derived quantities. Say example, say velocity, acceleration, force, momentum, etc. There are so many derived quantities. Now, unit. Unit of a physical quantity. Unit of a physical quantity. Second, a unit. What do you mean by unit of a physical quantity? Unit hai ta yakona measurement, say all measurement require comparison with a standard reference. That standard reference is known as unit of the physical quantity. Now, system of units. A CGS system. CGS system length, mass, time. So in CGS system, length is centimeter, mass is gram, time second. FPS system. In APS system, length is foot, mass is pound, time second. MKS system. In MKS system, length is meter, mass is kilogram, time second. Now in 1971, the General Conference on Weight and Measure Haibsina she moina anova system ama adopt the new system. New adopted system is known as SI. SI means System International. So System International. Sigi matungina there are 7 fundamental quantities. Seven fundamental quantities lay. I have 7 fundamental quantities in the kaino. Number 1, length. Length, meter. Symbol is M. And denoted by capital L. Mass, kilogram, kg, m, time, second, electric current, ampere. ये ना represent हुई temperature Kelvin K. Luminous intensity candela or CD. Then amount of substance. Then supplementary unit there are 2 supplementary units. Supplementary units in duty kaino hai tadi. Number 1, plane angle. Plane angle to radian. They are solid angle. They stay radian. Yes, sir. Now come to dimension. Dimensions and dimensional formulae. So dimensions of a physical quantity hai tadi kaino hai tadi powers to which fundamental units of mass, length, and time are raised to represent the quantity. Then dimensional formula an expression which tells us on which the quantity depends. And the nature of dependence. The dimensional formula is an expression. Now today I physical quantity dimensions is important way. So dimension of the velocity. Right. The velocity is we know the relation distance equal to velocity into time. So velocity की dimension distance, dimension of distance divided by dimension of time. So dimension of distance t l ni, time d t. So l t minus 1. So this is a dimension of velocity. Then say force. Say force around. Say force equal to mass into acceleration. So dimension of force is dimension of mass, dimension of acceleration. So dimension of mass is m, dimension of acceleration is l t minus 2. So this is m l t minus 2. Then density. So density is mass divided by volume. So density equal to dimension of mass divided by dimension of volume. Dimension of mass is m, dimension of volume is lq. So this is m l minus 3. Then pressure. Pressure is force per unit area. So dimension of pressure is dimension of force divided by dimension of area. So dimension of the force is ml t minus 2 divided by l square. So ml minus 1 t minus 2. Angular momentum. So angular momentum is defined as r cross p, where r is radius vector and p is linear momentum. So dimension of angular momentum denoted by L, capital L. So dimension of r, dimension of p. So dimension of r is L, dimension of p is m l t minus 1. So this is m l square t minus 1. Now coefficient of viscosity. Coefficient of viscosity. So viscous force is equal to 6 pi eta RV, where eta is a constant known as coefficient of viscosity, R is radius, V is velocity, we call terminal velocity. So viscous force acting on a body, on a spherical body of radius r moving with terminal velocity v is given by this. So coefficient of viscosity is equal to dimension of force divided by dimension of r, dimension of velocity. So dimension of the force is ml t minus 2 divided by l t minus 1. Velocity ml minus 1 t minus 1. See, that rasu kana the viscous force is equal to minus eta a dv by dx, where a is the area of cross section, dv by dx is velocity gradient. So dv by dx is known as velocity gradient. So from this we can find out coefficient of viscosity eta equal to force into dx divided by dimension of area, dimension of velocity. So this ml t minus 2 l divided by l square l t minus 1. So this is m l minus 1 t minus 1. So this is dimension of coefficient of viscosity. Then now say Stephen constant. Stephen constant. So Stephen constant is the E energy equal to sigma e to the power 4, where E is equal to energy per unit area per unit time. E is energy per unit area per unit time. So T is not second, T is temperature. Sigma dimension of Stephen's constant is dimension of E divided by T to the power 4. So energy CD energy per unit area per unit time CD ml square t minus 2 divided by l square t. Other city kind of m t to the power minus 3. Other m t minus 3 divided by k to the power 4. So dimension of Stephan constant is m t minus 3 k minus 4. Similarly, 11 class the physical quantities singi dimension latent heat lady, specific heat, pressure, atopa watpa mayam, Young's modulus, bulk modulus, the moment of inertia, atopa mayam lady go. Do them not away to number on Nainaraka, my physical quantity to Karino, the Masakanga Matunda, Magi dimension. Irailana EVI. How's 12 class class 12 key. Class 12 tanoi physical quantities in Adugi dimension Karamu Pakachi. Say arrive at the basic or but they house them charge, electric charge. Electric charge. Electric charge electric current is rate of flow of charge. So charge की dimension दी, current की dimension, time की dimension. So AT. Then permittivity of free space. So permittivity of free space. When a Coulomb's law if we have two charges Q1 and Q2 separated by a distance r, the force between the two charges is 1 by 4 pi epsilon naught Q1 Q2 by r square. So dimension of epsilon naught is Q1 Q2 divided by dimension of F dimension of r square. 4 pi is the constant enough with dimension if the Kanaroy. So city A square T square. Then dimension of force is ml T minus 2 L square. So this m minus 1 L minus 3 T to the power 4 A square. Then electric potential. So it charge at a point P which is at a distance r. the electric potential is 1 by 4 pi epsilon naught charge divided by distance. So therefore dimension of potential is dimension of charge divided by dimension of permittivity of free space, dimension of R. So this is AT, and dimension of permittivity of free space is m minus 1 L minus 3 T to the power 4 A squared into L. अगर सिगी माइट डायमेंशन दी कहता है m L square T minus 3 A minus 1. Now resistance, electrical resistance. Electrical resistance. देखो ना ohms law लेके गए from ohms law. So V equal to Ri. So R equal to dimension of R equal to dimension of V divided by dimension of I. So dimension of V is m L square T minus 3 A minus 1 divided by dimension of I is A. So this is m L square T minus 3 A minus 2. Now capacitance. Capacitance C. So capacitance C is equal to charge divided by V. So dimension of C is dimension of charge divided by dimension of V. So charge की dimension थी current into time. Dimension of potential is mL square T minus 3 A minus 1. So this is m to the power minus 1 L minus 2 T to the power 4 A squared. Now inductance L. So inductance L की देखो ना induce EMF. So E है again E equal to minus L di by dt. So dimension of L equal to dimension of E dimension of dt divided by Ti. Dimension of E is ml square T minus 3 A minus 1 into T divided by A. So this is M L square T minus 2 A minus 2. So this is dimension of inductance. Similarly, we can find out dimension of, say, what is the dimensions of L by R, RC root over LC. So हम जगह dimension से एकदम time बसा मानो नहीं. Answer ती कहनो time. मैं हम जगह dimension से time को मानो नहीं. हम उसे मेरा लाइन हॉट पे आई. हमारे हॉट का तो क्या है दादी? So L by R, dimension of L divided by dimension of R is ml square T minus 2 A minus 2 divided by ml square T minus 3 A minus 2. So see cancel the matunga. We will have the dimension of time. Similarly, you can find out this. Now, so there are physical quantities which have same dimensions. So physical quantities having same dimensional formula. Number 1, say frequency. Angular frequency. Velocity gradient. Say frequency की dimension सी कहनो T minus 1 नी angular frequency की सु मतलब कि velocity gradient ऐसी dv by dx नी. So dimension of dv by dx is lt minus 1 divided by L. So t minus 1. Then angular velocity omega is also 2 pi by t. So my dimension g at t to the power minus 1. Number 2, work done by a force. Kinetic energy potential energy torque moment of the force. I have a quantity thinking my dimension g ml square t minus 2. Pressure, stress, Young's modulus, bulk modulus, modulus of rigidity. So pressure is a force by area ni. So pressure ki dimension g, force dimension of pressure is force is ml t minus 2 divided by l square. So this is m l minus 1 t minus 2. Momentum impulse. Momentum is mass into velocity, impulse is force into time. So they have the dimension m l t minus 1. Acceleration due to gravity, then gravitational field intensity. So these three quantities have same dimension L t minus 2. truss. Weight energy gradient. So they have the dimension MLT minus 2. Angular momentum Planck's constant. So there the dimension ml square t minus 1. Surface tension spring constant force gradient. Is the dimension m t minus 2. Now, some physical quantities do not have dimensions, like say dimensionless quantity. Dimensionless quantity. Number 1, strain. Strain is change in length divided by original length. So delta L is change in length divided by original. So dimensionless. Number 2, coefficient of friction. So force, frictional force equal to mu r, where mu is a constant known as coefficient of friction. So mu is F by r. So F is force, r is also force, so this is dimensionless. Number 3, specific gravity. Specific gravity is the density of the body divided by density of water at 4 degrees Celsius. So specific gravity. Number 4, trigonometric ratio. Trigonometric ratio. So this is length divided by length. It is also dimensionless. Number 5, efficiency. Efficiency is useful work divided by work input. So it is also dimensionless. The refractive index. Refractive index is speed of light in vacuum divided by speed of light in the medium. Find the structure constant. So it is denoted by alpha. Alpha is E square by 2h epsilon naught C, where E is charge of the electron, H is Planck's constant, epsilon naught is permittivity of free space, C is speed of light. So dimension of alpha is, say, dimension of E square divided by dimension of Planck's constant, epsilon naught C. So this is A square T square divided by ml square T minus 1 for Planck's constant, m minus 1 L minus 3 T 4 A square L T minus 1. So this is 1 from now application. Application of dimensional analysis. Okay, number 1. To check the dimensional correctness of a given physical relation. The physical relation could be magi dimension left hand side ke right hand side ka mana gadam dimension mana gadam. For example, say we have relation S equal to Vt, say S equal to Ut plus half At square, so V equal to U plus At, so V square equal to U square plus twice As. So m, mass of a body. So mass of a body at rest divided by 1 minus v square by c square. So Fp equal to mv minus mu. So work done equal to change in kinetic energy. So any physical relation, see my dimension left hand side, right hand side dimension mana kita ni. See ama kata ngai pakai ke. For example, say number C yang C. So S equal to ut plus half at square. The dimension of left hand side equal to dimension of S is L, and dimension of right hand side, the first term, so ut lt minus 1 into t, so L, second term half a t square. So dimension of acceleration, dimension of t square. So lt minus 2 into t square. So this is L. Hence, so then it is dimensionally correct. Now second application is to convert a physical quantity from one system of units to the other. So n1 u1 equal to n2 u2. So n2 equal to n1 u1 by u2. So similarly we can convert from one unit to another unit. So example, so convert 1 Newton force into dyne. So dimension of force is mlt minus 2. Now one Newton equal to see example. deducing relationship among the physical quantities. By using dimensional analysis, we can derive a unit, a physical relation. Say, for example, say we can find out time period of a simple pendulum. And we can find out centripetal force, etc. So by using dimensional analysis,